Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to write polynomial functions with integral coefficients given a specified number of zeros. Before we get started, there are some formulas that we'd like to go over. These formulas will be implemented when we are carrying out our calculation process. Okay? So the first one has to do with the square of a sum. So let's write this down. Square of a sum. If you have a plus b square, this can be simply expanded to yield a squared plus 2ab plus b squared. We also have the square of a difference. In this case, if we have a minus b quantity square, the square of a difference, this can be quickly expanded to yield a squared minus 2ab plus b squared. The last one is known as the difference of squares. Difference of squares formula is as follows. If you have a plus b times a minus b, this can be expanded to yield a squared minus b squared. Okay, so these are the three formulas we will be implementing in the generation of polynomial functions with the specified number of zeros. So let's take a look at the instructions. The instructions are for us to write the polynomial function with integral coefficients that have the specified zeros. Alright, for number one, let's say we have the following scenario. We have a 0 of 3 with a multiplicity of 2, and then the other 0 is negative 1/2. Okay, so the first step is to set up equations that basically assign x to each 0 that is indicated to us here. So 3 with a multiplicity of 2 means what? It means that we have x equals 3 and another x equals 3 as solutions to the polynomial equation when set equal to 0. Okay, so the multiplicity of 2 means that we're going to have two zeros that have the value of 3. And then we have the last one, x equals negative 1/2. After setting up these three equations, by setting x equal to the zeros, we're going to set each equation equal to 0. Okay? So in the first one, we'll subtract 3 from both sides. That yields x minus 3 equals 0. The same procedure applies to this equation in the center. We have x minus 3 equals 0. And then lastly here, for the third 0, we might be tempted to add 1/2 to both sides. If we do that, even though it's a correct procedure, it will not meet the requirement to have integer coefficients. There's a great possibility that we'll have fractional coefficients if we add 1/2 to both sides and use x plus 1/2 as one of the factors. So to guarantee that we do not have fractional coefficients and that they are all integers, we have to use a different approach. To do this, we'll multiply both sides by 2. that yields 2x equals negative 1. And then lastly, we'll add 1 to both sides. Remember, our objective is to set each equation equal to 0. So we have 2x plus 1 equals 0. Now we are going to proceed to use the reverse of the zero product property. So what does that enable us to do? We can express the product of the left side of each equation equal to 0. Okay, so we have x minus 3 times x minus 3 times 2x plus 1 equal 0. All right, now we'll proceed to expand this. If we take a look at the first two zeros, when you multiply multiple factors, you want to do it 2 at a time from left to right. Okay, so x minus 3 times x minus 3, these are identical factors, so they can be expressed as x minus 3 quantity squared times 2x plus 1. Now we can take advantage of the square of a difference formula that I showed you earlier. A minus b quantity square is equal to a square minus 2ab plus b square. In this case here, a is x and b is 3. If we apply the formula here, it will give us the expanded form, a square, which is x square, minus 2ab, 2 times x times 3 is 6x, plus b square is plus 9. Okay? Now we'll multiply this trinomial by 2x plus 1 equals 0. Now we're going to multiply these two polynomials, a trinomial and a binomial, using what is called the box method. There are other methods that can be employed here, but I like to use the box method. Anytime I'm multiplying a trinomial or polynomial with more than two terms with a binomial or another polynomial with 2 or more terms. Okay? So we're going to have 3 columns for the 3 terms of the trinomial and 2 rows for the 2 terms of the binomial factor. Okay, so let's put x squared minus 6x plus 9, the first factor on the top, and then we'll align the second factor, 2x plus 1, vertically on the side here. Now what we have created is basically a multiplication grid. The nice thing about this is it keeps everything organized and it's very easy to avoid making mistakes. Now, let's multiply them out. We have 2x times x squared, that yields 2x to the third. 2x times negative 6, you get negative 12x squared. 2x times 9 will yield 18x. Now let's go to the second row. We have 1 here, so the multiplicative identity will simply have x squared minus 6x plus 9. To finish off, we'll just simply combine like terms, okay? Now, 2x to the third has nothing to be combined with, so we have f of x equals 2x to the third. Now the next diagonal, we have these two terms right here, x squared and negative 12x squared. These two can be combined to yield negative 11x squared. Next diagonal, 18x and negative 6, combine these two. That will yield positive 12x. And then the last constant right there has nothing to be combined with. It stands alone. And this, ladies and gentlemen, is the polynomial function with the zeros indicated earlier. All right, let's consider another example. In this case, let's say that we have the following zeros for question number 2. We have 1/2 and 3 plus root 2. So we are still following the same instructions to write the polynomial with integral coefficients that have these zeros. So first thing we're going to do is set x equal to all the zeros here. So we have x equals positive 1/2 and x equals 3 plus root 2. Now question, are these all the zeros that the polynomial function has? The answer is no. Anytime we have a radical component as one of the zeros, an irrational root of this nature, its conjugate is also a root. So what does that mean? That means that another zero that's implied to exist based on the existence of this root is x equals 3 minus root 2. Okay? So these are the 3 zeros that the polynomial function should have. So we'll advance to the next step. Now the first one we want to set equal to 0. Same applies to the other two. For the first one, we'll multiply both sides by 2. As we did in the previous example, we have 2x equals 1. And then we'll proceed to subtract 1 from both sides. And that yields 2x minus 1 equals 0. Now let's take a look at these two right here. These ones involve a radical component to them, so we want to be strategic in our approach. So let's group the terms together, and what we're going to do to set them equal to 0 is subtract them from both sides as a package. Okay? Let's do it. So we'll subtract the quantity 3 plus root 2 from both sides of this equation. What does that give us? We have x minus 3 plus root 2 equals 0. If we take a look at this equation to the right, we'll apply the same procedure. Subtract 3 minus root 2. And that yields x minus 3 minus root 2. And that is equal to 0 also. Now, what we want to do is to set up the equations in such a way that we can take advantage of the difference of squares formula in the expansion of the product of these two roots to the right side. Okay? So to accomplish that, we'll regroup the terms here. Okay? Let's go ahead and do the regrouping. We're going to have x minus 3. And then when we distribute this minus to this positive root 2, we'll have minus root 2. And that is equal to 0. The same here, regroup. We have x minus 3. If we distribute this minus to this minus here, it becomes positive root 2 equals 0. Alright, bring this down, 2x minus 1. Now, we're going to use the reverse of the zero product property to express this zeros as a combined product, which is equal to 0. Okay? So we have quantity 2x minus 1 times x minus 3 minus root 2 times x minus 3 plus root 2. Set that equal to 0. Now what you notice here is that we have the sum and the difference of two terms. So this can be considered as a and this b. So you see a and b here again. So this is a. Let me correct that. This is a and this is b. Okay, we have the difference here and we have the sum. So we can take advantage of the sum and difference formula. You remember what the difference of squares formula. You remember what the difference of squares formula is? A squared minus b squared is a plus b times a minus b. So these two quantities here can be expressed as the difference of squares. The squares are going to be a squared and b squared, where a is x minus 3 and b is root 2. Okay, now let's go ahead and do it. We will now have 2x minus 1 times a squared is the quantity x minus 3 squared minus b squared, which is root 2 squared. That's the condensed form of the sum and difference of two terms, the product of two terms, okay? So set that equal to 0. Now let's proceed to simplify further. If you look at the term on the right side here, we bring down 2x minus 1. We have x minus 3 squared. We can use the formula that we went over earlier. X minus 3 squared is the square of a difference. So that can be written as x squared minus 6x plus 9. And then minus the square root of 2 squared is 2. Equals that equals 0. Now let me show you the formula that I just used. A minus b quantity square is a squared minus 2ab plus b squared. So that's exactly what I'm applying here in the expansion of x minus 3 squared. So let's see what we get. We have 2x minus 1 times x squared minus 6x. We can combine 9 and 2 to get plus 7 equals 0. Now, we are now going to multiply this binomial by this trinomial expression. We can take advantage of the box method again just to help simplify the process and minimize the risk of making mistakes. Okay, so let's go ahead and do that. I'm going to have 2 rows and 3 columns. So on the top we have x squared minus 6x plus 7. And then we have 2x minus 1 on the left side here. Now let's multiply them out. Alright, so 2x times x squared gives us 2x to the third. And then let's continue multiplying. 2x times negative 6x gives us negative 12x squared. 2x times positive 7 gives us 14x. Negative 1 times x squared gives us negative x squared. Negative 1 times negative 6x gives us positive 6x. And then negative 1 times 7 is equal to negative 7. Now let's combine like terms to get the final result. So the function f of x is equal to 2x to the third stands alone. We can combine negative 12x squared and negative x squared together to yield negative 13x squared. We can combine 14x and 6x to yield 20x, positive 20x, and then we can just bring down the negative 7. Okay, so there goes your final answer, okay? That's the polynomial function with the indicated zeros at the onset of this problem. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study of polynomial functions, do give us a thumbs up. Your positive feedback is very valuable to us. Questions and comments can be included in the comment section below, and we'll be glad to address whatever concerns you have. Do not forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.